begin by taking a look at this function f of x, that is x squared minus 8x plus 15. So this is called a quadratic function because of the x squared. And every quadratic makes a parabola as its graph. So let's take your calculator and graph x squared minus 8x plus 15. Pause the video and get this typed into your calculator, and then hit graph when you're all set, and hit play. So our function here, it passes the vertical line test. It's not a one-to-one function because it doesn't pass the horizontal line test. The parabola is going up because of the x squared, and we can see its turning point, or its relative minimum, is down in the fourth quadrant. And we can also tell that the zeros of this function are at positive 3 and positive 5, because that's where the function crosses the x-axis. So we can find the zeros of a function graphically, but we can also find the zeros of a function algebraically, and that's what we're going to look at today. Finding the zeros algebraically, I'm going to replace the f of x with a 0, because that's what I want to do, is figure out when this expression is equal to 0. Now, in order to do this, this is where your factoring skills come in, because we can break this x squared minus 8x plus 15, this trinomial, into the product of two binomials. So what we need to do is think of numbers that multiply to 15 and add or subtract to 8. So I know I need an x and an x in the front, and numbers that multiply to 15 and add or subtract to 8 would be 5 and 3. And minus plus in the trinomial always has to be minus minus in the parentheses, so that they multiply to become positive, but add to become negative. And we'll put our equal 0 here. And now keep in mind what this is saying. X minus 5 times x minus 3 is equal to 0. So that means I am multiplying two things together and getting an answer of 0. So that means either one or both of these factors has to equal 0. So we do Mr. Squiggly, and we say x minus 5 could equal 0, or x minus 3 could equal 0. And when we solve for x, adding 5 to both sides, we get x equals 5. And on the other side of Mr. Squiggly, adding 3, we get x equals 3. And those are the same two zeros that we got when we graph the function. Now let's try to find the zeros of this function, function g, without graphing. So we're going to replace our g of x with a 0. And now when we go to try to factor this trinomial, 3x squared plus 2x minus 8, this is a little more difficult to factor because of the 3 that's sitting in the front. So we have a couple of options. We could guess and check pairs of factors for 3 and pairs of factors for 8 in the back, and then see what combination of the outers and inners will make us the 2 in the middle. If we don't want to guess and check, we can split the middle with this, or we've also been calling it factoring by grouping. So if I want to factor this by grouping, I'm going to take this 3 and multiply it by the 8, which gives me 24. So now I'm trying to think of numbers that multiply to 24 and can add or subtract to make a positive 2. Well, 6 times 4 is the first numbers that occur to me. It makes 24, and 6 and 4 we could make a difference of 2. So we are going to take this 2x and split it into 6 and 4. Now notice my signs in there. Positive 6 minus 4 is what is equivalent to positive 2. And now we've got a greatest common factor of the first half of 3x. And when I divide both those by 3x, I'm going to get x plus 2. And in the back half, my greatest common factor is negative 4. And dividing both of those by negative 4 is going to be x plus 2. And notice that in my parentheses, I have the same factor there of x plus 2. So when I pull that x plus 2 out as my common factor for both halves, that's going to leave me with 3x and a minus 4 as my other factor. And notice here, if we were to FOIL out x plus 2 times 3x minus 4, that would take us back to 3x squared plus 2x minus 8. Now, we're still not done here. All we've done is factor this. Now we need to find the zeros. What values of x, when we plug them into these binomials, will make the product be 0? So Mr. Squiggly is going to come along here. What number plus 2 would make 0? Well, negative 2. Over on the other side of Mr. Squiggly, what number would make 0? Well, add 4 to both sides, and then dividing by 3, x would be 4/3. And then I could check to make sure those two values are right, either by substituting them back into the original equation and making sure we get a 0, or by graphing it on our calculator. And it would certainly appear that we cross the x-axis at negative 2 and just a touch over 1.